Assalamualaikum and good morning everyone. My name is Abdul Hanif bin Abdul Rahman. My number metric is B24761185. So today I will be presenting about my individual assignments, which is probability in statistics in information technology. So here we go. So we go to the introduction, which is probability vs statistics. Did you know what is probability and what is statistic? So first, probability. Probability is a forward-looking, which is probability is starts with a model and predicts the likelihood of outcomes. Example, predicting data from assumptions. And then statistics. What is statistics? Is a backward-looking. We start with observed data and builds model to expand or predict patterns. Example, inferring stole from data. So together, these concepts is allow the IT professional to manage uncertainty and detect anomalies and make evidence based on security division. So we go to my first task, which is task A, cyber. I choose a cybersecurity scenario. The title is a phishing email detection system. As you know, an email security system uses filters and machine learning to classify incoming email, which is the email is safe or malicious, or we call it is phishing. So what probability can helps? The probability helps measure the effectiveness and reliability of the system by quantifying the chance of correct decision versus error, which is false positive or negative. So when the correct delivery, the system correctly identifies and delivers a safe email. And correct block, the system correct identifies and block a phishing email. That's why I use a phishing email detection system for this probability. So the next is a basic probability calculation. For the task A, the scenario is 1,000 daily emails. This is 100 is safe and 200 phishing is email from phishing email. And so here the calculation that I get is a P safe email 0.98. Safe email accuracy 0.92 and phishing accuracy 0.69. So here the correct decision, P is the correct decision. So I calculate 0.92 multiply 0.8 and then I plus 0.96 multiply 0.2 and I get 0.76 and I plus 0.192, so I get is 92.8%. So the overall system accuracy is 92.8%. So we go to the conditional probability and risk for task A. So conditional probability determines the chance of an event given prior knowledge. So P is a system accept or email is safe. If we know the email is safe, the chance the system that is true is 92% by 736 divides 800. So here the answer. And then real world implication, the 7.2% error rate represent risk from false positive, which is a block safe emails, and false negative allow the phishing email. We go to the task B, monitoring cyber threat trends. So here is a alternative scenario. I choose justifying security investment. As you know, a cybersecurity analyst needs to determine if stronger security tools are needed by monitoring phishing frequency. Example, first collect data, 10,000 email received in 1 month. So we want to know 2 were phishing attempts. So we calculate. And then basic probability, overall probability of phishing is 200 divided by 10,000. So we get 2%. This is a basic probability functions. So we use in the monitoring for cyber threat trends. Then conditional risks and trend analysis for the task B. So by using probability and statistics, we want to focus security efforts and predict future attacks. So we don't know what future trends. So this conditional risk is probability and it's very can help the team. So if an email contains a suspicious link, what is the chance is phishing? So 150 out of 300 suspicious looking email where phishing is 150. We divide 300, so we get 50%. So here the risk jump from 2% to 50% if an email has a suspicious link. So it's allowing the IT team to focus for the spam filters. So at the right corner, you can see the statistical trend. Phishing attempt are increasing by 10% each month. So the trend analysis predict 220 phishing email for the next month. So this is a justifying proactive measure. And lastly, conclusion, transforming uncertainty into knowledge. Probability and statistics are essential tools for modern IT security, transforming guesswork into measurable risk management. So we have measure risks for better future flow, for data driven and safer decision environment, and mostly is a system accuracy. That's all from me. Thank you.